guys, welcome to Science at Home. My name is Heather and I'm joined with my colleague Dr. Rok, and today we're going to be answering some of your questions that you've been sending through to us. Now, hi Rok, how are you?
Hello.
It's a bit of a different perspective that we have this time. I mean, the last time we were talking to each other, we were still in the office.
Correct, yes.
Yeah, this is a bit weird, but it's great though that we can still do this, you know, through video conferencing. So I hope you don't mind, but I've themed up the question and answer session today, and we're going to be talking mainly about comets and asteroids. Is that okay?
That makes sense. Yes. It's close to my topic expertise.
Excellent. So the first two questions were the most commonly asked questions by the public, and it's questions that we would get all the time in the planetarium. So the first question for you, Rok, is what is an asteroid?
Yes. Well, so the thing is, the solar system has lots of things in it, right? The sun, of course, famously. Also, the 8 planets.
Yeah.
We like Pluto. It's not a planet. The 8 planets. And then essentially what is left there are moons of the planets, which are already the category I'm about to define, which is the minor bodies, or the small bodies of the solar system, which is this giant group which has everything in it that isn't planets or the sun. And definitions within there are kind of fluid, but essentially you can define an asteroid as a rocky body in the solar system, most of them to be found in the asteroid belt, which is between Mars and Jupiter, but also in other places, which we could discuss if there's time for that. And it stems from the early period of the solar system, where we think that essentially either they didn't have enough gravity to pull themselves together into bigger clumps to make a planet, or maybe the parts of it were sort of a protoplanet, which was then torn apart by, for example, Jupiter due to gravitational forces. So these are those sort of 2 main types. And within asteroids themselves, we also have kind of rubble piles, as we call them, which essentially would be as if you had like a really big pile of sand just sitting in space, self-gravitating, and other ones which are more solid, so more like, you know, metallic or proper rocks. So yeah, that would be your basic definition of an asteroid. Most people will think about the asteroid belt, but they're actually to be found everywhere through the solar system.
Yeah, and so then the second question is, what is a comet? So what is the difference between a comet and an asteroid?
Yes, a comet, again, falls into the small bodies of the solar system category. And the main difference between a comet and an asteroid would be the asteroid is, again, well, the more we learn about these things, the more blurry the lines are. But the comet, the asteroid will be dry, will have just rocks or sandy stuff. Whereas comets will also have icy material and will generally be even less well formed in a sense, because they stem from a different part of the very early solar system when there were still various ices. And when I say ices, I mean not just our normal water ice, but also other things, such as carbon dioxide ice, we also know dry ice, nitrogen ices, various ammonia ices, various things like that. So it's really cold, and all those things will come together to make a comet, as opposed to just the dry, rocky, sandy stuff, which would make an asteroid. Now we have had mission to the Dawn mission went to several objects in the asteroid belt, including Ceres, minor planet closest to us, and found on most of them some evidence of water. So it's not very cut and dry that, oh, the asteroids are the dry ones and the comets are the wet, well, they're not wet, you know, the icy ones. And indeed, the thing about comets that's particularly distinguishable from asteroids, oh yeah, if you bring those materials close to the sun, they will make a tail as the comet moves through the solar system, whereas an asteroid won't make a tail, which again is a fluid definition, because if you bring anything close enough to the sun, it will fall apart because the sun is very hot. So actually there are some objects which we know which have designations, you know, the official designations that we use both for an asteroid and a comet, because originally we thought it was an asteroid and then we saw it has some activity, so the line is a bit blurred.
Yeah.
But those are the 2 main separations.
Yeah.
Tail, no tail.
Yeah. One thing I forgot to add at the start is that people can ask us questions throughout our conversation here. We will be replying in the comments section. So we've got the definition then of what is an asteroid and what is a comet. And another common question that was asked of us was, are there more asteroids than comets? Is that something we can easily tell?
No, it's not something you can easily tell. We can make some estimates, however. So, for example, there's a number which you can get, so 150 million objects, I believe, of in the asteroid belt, above 1 kilometer in size. Okay, this is a quite a large number. On the other hand, you have, well, actually, these aren't the only asteroids. There's actually lots more, and 1 kilometer is actually a pretty big asteroid. You have lots of smaller ones. So that number would probably be, I don't know, maybe closer to 1 billion, really, if you get right down to it. Whereas actually for comets, we only have some thousands of observed and labeled comets. However, we also have, well, the source of comets should be the Oort cloud, which is very far out, and we expect in there to be possibly around 1 trillion. So we think there should be more comets than asteroids. But it's really sort of big numbers that we don't actually know. We're just guessing, and making estimates from what we see.
Yeah. So I don't know about you. I'm getting quite used to working from home here and being on my laptop. Video started playing while we were talking there, so that's why I did a little, oh, sorry. But I'm sure everyone who's working from home is experiencing these problems. Okay, so now this is something that I quite enjoy, and I'm glad that they were asked this question. So Rok, what is the most famous comet?
Well, there's the easy answer to that question.
Yeah.
It is the comet which has been appropriately designated as 1P Halley.
Yeah.
The first one on the list. So Halleys Comet, and P stands for periodic, by the way, if you're wondering.
Okay.
Yes, there's a list of periodic comets, and Halley is the first one on the list. So that's the famous one. Everyone's heard of Halleys Comet.
Yeah.
It's been seen through centuries. Halley didn't actually, well, wasn't the first to observe it, because usually we name comets after the first observer. Halley didn't properly observe it, if I recall correctly, at all. He just did some calculations based on other people's observations of what they thought were possibly separate comets, and discovered, oh, actually, those have exactly similar orbital parameters. And if I combine these together, we can get an orbit for this comet, which would therefore predict it to come again. I don't know how long from when he wrote that, but and indeed he was right. And so in honor of his really good maths, we named it after him. But it's been seen, 1066, the invasion of
Battle of Hastings.
The Conqueror, Battle of Hastings, exactly. The Bayeux Tapestry, which I probably mispronouncing, has a comet in there, and Halley's Comet did go past that year, so that's the one.
Yeah,
the other. Yeah, sorry.
I was just gonna say, when it comes to like famous comets, that's whenever I sort of nerd out, because the historian in me is just like, dates. I need to know these dates. So Edmund Halley did, as she said, mathematically predict it, and then I just thought it was so great that they said, you know what, this guy did something really amazing. Let's name the comet after him. And a lot of people watching us right now will probably remember the last time Halley's Comet was in the sky, which was 1986. But it'll take a while before we can see it again. What other famous comets
2061
are there?
or so, yes.
Yeah, 2061.
Yes. The other famous these days is, of course, Comet 67P, Churyumov-Gerasimenko. That's the comet that Rosetta mission visited. Was orbiting around for 2 years, tried to land the Philae lander. Well, did land the Philae lander, and finished the mission in end of September 2016. So that's got a lot in the public mind these days. But there's also others. Comet Hale-Bopp from 1997, I think, which was seen quite nicely. We have a nice photograph with the observatory and the Comet Hale-Bopp above it. As well. So it was actually Halley 1986 wasn't quite as bright as we had hoped it might be. So some people were slightly underwhelmed, but luckily, 10 years later, we had a really good one.
Comet Hale. So another question, just surrounding comets, that people want to know is: have we ever seen a comet hit something or hit anything? Like, has one ever hit the Earth? Has one ever hit any other planets?
Yes. So there are several bits of that, because you asked several bits of the question. So as far as the Earth is concerned, actually meteor showers are not comets falling, so just to say that first, but they are bits of cometary dust from the tail of comets as the Earth passes through that part of the orbit. So we're getting comets onto Earth all the time, but it's just in tiny little pieces. Then additionally, in 1908, there was the Tunguska event, which in the middle of Siberia, so no one actually saw it, but it was quite impressive, and sort of a big explosion above the ground and then flattened trees, etc. And we think it might have been a comet, because we think a comet would be more likely to explode like that, more so than an asteroid, because it has all these gases and so on, the ices, which will turn into gases as they go through the atmosphere. It's not clear yet, but we think it might have been a comet. So that was last time that we know a comet hit Earth, probably still not a very big one. But we had quite a display on our hands when comet Shoemaker-Levy 9 hit Jupiter. So Jupiter is really good at this sort of thing. So on the one hand, as I said, probably caused a protoplanet in the asteroid belt area to fall apart because of its strong gravitational pull, which is slightly complicated. So it didn't just fall in Jupiter. But on the other hand, it also catches for us most of these stray things that go around the solar system. So it's keeping the neighborhood a bit cleaner for us. And that happened with Shoemaker-Levy 9. It went rather close to Jupiter, and it actually went so close that it got directed into it. And we had some spectacular imagery, which, if you just see the photos that Hubble Space Telescopes and others took, maybe it's not that spectacular until you remember how big Jupiter is. And then you see sort of big patches on the surface, some of which are larger than the Earth. So that's quite spectacular. And sort of, the comet broke apart into several pieces and fell in.
Yeah,
I can't remember what year that was in.
I know, it was in 1994. Again,
94.
historian.
Yes, I knew it was the 90s. I couldn't remember exactly the year.
I know, yes. And again, like, giving away my age, I was 4 when that happened. So, like, it's not that long ago, but it's kind of long ago now. Oh, I'm so old. So, like, you mentioned about how meteor showers are like, little comets coming down, and like that's the leftover debris left over from the comets. But another question we had was, do asteroids hit the Earth all of the time? So is there a difference in these meteor showers? Like, do some come from comets? Do some come from like dusty asteroids or something?
No, the meteor showers wouldn't come from dusty asteroids. However, asteroids could also, so very small ones, could also account for some of the meteors that we see. Indeed, there's the whole series of words, meteor, meteoroid, meteorite, etc. And for the small pieces which are hanging out there, will fall down into a meteorite, and then if there's a bit left over, that's the meteorite. But there usually isn't, because they are, again, quite small pieces. So that does happen all the time. It's more random than comets, because it's just whatever happens to be nearby. And they're pretty small. So there's really not much to worry about. Very occasionally you get slightly larger bits of asteroid. So you will get in news about a couple times a year usually. Oh, this asteroid the size of, I don't know, Ben Nevis or Mount Everest or whatever is going past the Earth only this close, and actually only this close is actually still quite far away. But sometimes something a couple 100 meters in size could again hit us. So, for example, the Jellybeans.
I was just about to say, yeah. So what happened there with that? Did we see it? Did we not see it? Like, was it? Well, was it a surprise, basically?
It was a bit of a surprise, but it shouldn't be too surprising that it was a surprise, because it is quite a small object. And luckily, despite actually going over a reasonably populated area of Russia, because Chelyabinsk is quite a big city and relatively big cities nearby, had no victims to it. Because as it was going through the atmosphere, again, it actually did explode. So it's not only comets that do this, which is why I'm not sure about Tunguska event if it was a comet or an asteroid. And that explosion broke glass and windows in quite a large area. So actually, that glass is what injured people, but there were no deaths from that. But yes, essentially around that time that the Jellybeans event happened, we were tracking one or two other near-Earth asteroids, as we call them, NEAs, or sometimes NEOs, near-Earth objects. And we knew that those ones wouldn't hit us, but sort of with them came the little one as well. I'm pretty sure. Yeah.
Yeah, I mean, like, isn't it right in saying that the Jellybeans meteor or meteorite is one of probably the most well-documented instances that we've seen because of all the dash cams in the cars? Exactly.
It's a fortuitous coincidence that the Russians have lots of dash cams for insurance purposes, which is now sort of spreading around Europe a little bit as well. But at that time it was more Russia than elsewhere. So yes, and it was in the can't remember the time of the day anymore. But I think it was close to one of the rush hours, so there were even more cars in the street than might have otherwise been.
Yeah, and like all that footage can be found on YouTube, and like whenever it did explode, the flash that it gave off was just
it's fantastic to look at.
It was brilliant, yeah. I mean, like that was only in 2013, so you know, I remember being on the news then. It was like, oh my god, this thing could have hit us. So
well, as again, it kind of exploded above the surface.
Yeah,
so it really hit anyway. And actually, a couple of years later, so the problem with seeing these things is that, well, actually, Russia's pretty big and pretty empty still to this day. But still, most of the Earth is water. So there is actually an object which is a bit bigger than the Jellybeans meteor, which caused an event spotted by some satellites, I'm pretty sure, off the coast of South America, so in the South Pacific Ocean. But you know, there's not much there, so it only happened to have a lucky chance to something to be looking at that area. So this could be happening a bit more frequently than we see.
Yes.
But, yeah.
Would I be right in saying that, you know, probably the largest meteorite on Earth is probably at the bottom of the ocean? I mean, no one's going to go down there and find out, really.
Yeah, I mean, the odds are in the favor of that. So although oceans also kind of change quite quickly on geological timescales, so maybe it's already hidden down in the mantle or something.
Yeah. So you talked there about near-Earth asteroids, and one of the questions that we had was, are there any large asteroids close to the Earth? And you mentioned how we see, like in the news all the time, like, oh, a bus-sized object is coming towards us. So
bus size probably wouldn't even get the news article. But,
okay, so something the size of Mars is coming towards us.
Okay.
So are there any large asteroids close to the Earth that we're currently watching, or you know, what are your thoughts on that?
Well, so essentially a near-Earth asteroid is defined as something that comes within 1 AU of the Sun, which is basically around the orbit of the Earth, because everything will have an orbit. So actually, if the closest part of the orbit is within that area, then it might at some point intersect the orbit of the Earth. But of course, you have to think about it in terms of 3D space. So most of the time, it won't hit the Earth. And not just that about 3D space, it's also about time, because of course, there could be lots of things going where the Earth was half a year ago, and we're perfectly safe on the other side. We do keep a track on lots of them. There's lots and lots of projects tracking the near-Earth objects, lots of which are asteroids, some of which are also comets. So we have a very good handle on everything over 1 kilometer in size. And we're trying to get the numbers up for the smaller ones as well, but obviously the smaller it is, the harder it is to see unless it gets really close. But smaller than 1 kilometer is also not that dangerous. And we know that the ones bigger than that we've mapped, which is almost all of them. Of course, I can't guarantee we've checked all of them, but you know, we have pretty good telescopes, and with the years, you know, our abilities only improve. We get, we are pretty certain that nothing's about to hit us that would require something like, you know, Armageddon, the movie.
Which
to play out.
I could do a whole conversation about why Armageddon is just. Now, I'm not even going to get into it. Why would you train people, diggers, to be asked? I don't know. Anyway, I'm not going to go off on a rant. Now, quite a good question that came through, and I really want to know the answer to this, is do comets have a smell?
Yes, it turns out they do. Yes. Well, I suppose that's a natural question because I'm talking about, oh, yes, these ices and then turning into gas and so on. And some of you might know that I was talking about dust tails. There is also a gas tail, and that gas might have a smell. And it turns out that yes, it does. It does have a smell. It's not a very pleasant smell, though.
Is it not? Oh dear.
No. Well, so the main components of the smell would likely be hydrogen sulfide, so that's rotten egg smell. And the next one might be ammonia, which is sort of that sort of thing.
Yeah.
Yes. Third one is cyanide, which actually smells pleasantly of almonds, but you wouldn't want cyanide either. So
the smell of almonds can cover up, what was it you said, cat pee and rotten eggs? Yes, I will take that any day.
Yes. And even if it could, it's still cyanide. So yes, another presence of substances.
Oh, gross. But you know what? Gross space is the best space. So we're coming near the end now.
I will say, however, if you're out in space trying to smell a comet, I'd worry more about the lack of air than about how bad the comet smells.
Yeah, don't take your helmet off in space, people. That's not a good idea. So
just a public service announcement there.
This is me now testing. This is a question from me to see if you know this question. Rok, what is the largest meteorite on Earth?
So the largest piece that fell, and we did find Uba meteorite in Namibia.
Excellent. Do you know how heavy it is?
No.
It's 60 tons.
Oh, that you know.
60 tons in weight. Yeah. It's a national treasure there. You can go and stand on it, take your picture with it. I mean, no one's going to steal that thing. It's quite awesome to see. You can Google the images of it. It's really quite good to look at. And finally, a question that came through for us was, when is the next time I can see a comet?
Yes, that's a hard one to answer. So again, we were saying, Comet Halley was 1986, very good. Next time, 2061. That's a bit away still. And actually wasn't as spectacular in 86 as we thought it might be. We think the 61 is going to actually be pretty good, so we can look forward to that.
Okay.
But before that, yes, there will be lots of comets before that. So we're kind of, by just looking at statistics of what we've seen, we kind of expect one great comet, because in the previous centuries they used to call them, the great comet of 1911 or a great comet of 1875. I don't know. I'm making numbers up at the moment, which would be the really bright one that everyone knows about.
Yeah.
And we expect one of those every decade, more or less.
Okay.
Yes, expect. Now again, this is not we didn't trace all the orbits and say there should be one because it turns out that these really bright ones are usually the ones that go really close to the sun, which means their orbits are really elongated. Actually, it means they come from really far away. So we don't actually see them until they get reasonably close.
Okay.
So we don't know they are out there until we already see them coming, and then some of them will fulfill the promise of being a very good comet. And actually, for example, in 2011, there was Comet Lovejoy, which was gorgeous over southern hemisphere skies. Sadly, not as much in northern hemisphere. We're overdue in the northern hemisphere for a good comet show.
We need a good comet.
Yes, there is actually a comet coming in at the moment, which looks like maybe in May and June could at least be naked eye object at night.
Okay.
But it's too early to say yet how bright it's going to get. Yes.
Yeah.
There's a tail across the sky or anything like that.
Yeah. Sorry, you did mention something there about Halleys Comet, about how the 86 one was not as bright as we'd hoped, but how the 61 might be brighter. So can I just ask for my own benefit, why is that? Why was it dim one time and then might be bright the next time? Is it not getting smaller as it's going around the sun, or?
Oh, sure, it is getting a bit smaller every time, but actually Halleys Comet, because we looked at a couple of comet nuclei at this point, including C7P, of course. Halley was one of them, and a couple others. Halleys is the biggest one we know of.
Okay.
And even 6-7P doesn't exactly, lose half its mass every time it goes close to the sun. It loses a small fraction. So it'll keep going for a long while, still making a tail. And Comet Halley even more so. It will be still going for quite a while, especially with 74-year orbit. So it's not that close to the sun at the far end. It's actually sort of around as far as Neptune is, whereas 6-7P only goes around Jupiter and then close, and around Jupiter and close. So it's a bit hotter where it is. The answer to your actual question there is that it's just the positioning in space.
Right. Okay.
Yes. So the Earth should be in a better place to see it better when it's bright.
Right. Okay. I get you. Well, Rok, thank you so much for answering all of our questions here today. I know it has been a bit of a different setting. Thank you so much for chatting with us. Guys, thank you for joining us here for Science at Home. And if you have any questions, please do send them through. We'll probably have Rok back on answering questions in the coming months. Thanks again, and have a nice day.
Before we sign off,
oh yeah,
I have a secret. I had a dog in my lap the whole time.
Oh, brilliant. The joys of working from home. And I bet that's just brought a smile to everybody's face. Guys, thank you so much, and we'll see you soon.
Bye.